In recent years, we noticed the deterioration of marine waters due to multiple pollutants. A case study developed in coordination with Ifremer aims at locating the sources of the leaks following a shipwreck, or, conversely, sources of fresh water for domestic consumption. We started with a simple configuration, where a fleet of 5 autonomous underwater vehicles, called Asterix and equipped with salinity sensors, will locate a source of fresh water without human intervention. We choose cooperation strategies with the pooling of information from each vehicle to exploit the advantages of using a fleet of vehicles and to reduce the time of exploration. A campaign day on a coast boat with 5 Asterix indeed costs about 16,000 euros to Ifremer. The first challenge is due to the difficulty of establishing reliable communication in underwater environment. This is a key point for ensuring an effective cooperation. Indeed, the data rate is only a few hundred bits per second, the transmission delay is around a second, and about 10% of items are lost. A second challenge concerns the monitoring of formations. In this first phase of exploration, the vehicles move in a V-shaped formation. Once an agent detects a significant change in salinity, it transmits this information to the others. Then, the fleet enters a phase of consolidation. In this phase, the fleet is regrouping into a circular shape. With such a formation, the movement is slower than with the V formation. However, there is a greater flexibility to move in all directions. Also, the distribution of submarines around the circle allows a more precise localization of the source. It is also possible to conceive any other type of formation. The shape can be elastic, that is, it deforms to adapt to its environment, to follow a path or to avoid obstacles. To form and maintain this formation, the submarines must exchange messages according to their relative position to the center of the formation. Although exchanges of all the data would allow a faster convergence of the fleet to the formation and its better maintenance, only those of the nearest neighbors are actually needed. Finally, this structure is robust to geographic constraints, limited flow and data loss. In order to fulfill the objective of source seeking, we developed a decision algorithm. It is also based on data exchanges between neighbors to ensure the same robustness with respect to communication constraints. It must allow all submarines to agree on a direction for the formation to move towards the source. One can imagine extending this type of algorithms for other applications, such as contours seeking to delineate the extent and evolution of a polluted area. This scenario of research led to the creation of the NRR Connect in 2007, whose objectives contain the development of this simulator with our industrial partners Prolexia and Robosoft. This activity is ongoing within the European project FeedNet Back.